Okay, let's work a problem from chapter 10, 10.1. This asks us which of these atoms or elements can never be the central atom in a Lewis dot structure. Remember, when you make your Lewis dot structures, you have to choose an atom in the center that's bonded to multiple other atoms. And some elements can be the central atoms and some can't. And this is kind of a nice problem because it gives you a little bit of knowledge as to which elements might be in the center, because you got to propose Lewis dot structures. Okay, so let's just go through this, and this will be some common elements, and I think you'll come up with some useful rules. So the first one is oxygen. Is oxygen allowed to be a central atom? And I'll say yes. It's possible. Doesn't mean it's common, but in some cases oxygen atoms are in the center bonded to multiple things. And one example I can think of is like ozone, for instance, O3. There's a bond from a central oxygen to two other oxygens. Okay, so it's definitely possible with oxygen. Doesn't mean it's common. I think usually, most often, most chemical compounds, the oxygen may be on the periphery and not be a central atom, but it's certainly possible. There's nothing that forbids it. Now, in the case of helium, generally speaking, helium is not going to be a central atom in Lewis dot structures. In fact, helium generally doesn't combine with anything. It's very unreactive. It's one of our noble gases, right? So you're not going to see it as a central atom in a Lewis dot structure, okay? On the other hand, we have fluorine gas, okay? I'll go with no on this one, but I guess it's a little less of a hard no than helium, but fluorine usually only forms one bond. And that's because it's one of those halogens. Highly electronegative halogen. It likes to form one bond with something else so that it can share a pair of electrons in covalent bonding model and complete its octet. And once it forms one bond, it's got its octet, it's happy. And a condition for an atom being a central atom is it needs to form at least two bonds, sometimes maybe 4 up to 6. So fluorine really only likes to form one, and because of that, it tends to not be a central atom, except under perhaps some sort of extreme cases that we don't really talk about here in the class. Hydrogen. Okay, this one gets a big no. Because hydrogen, that first element, always reacts to complete its 1s atomic orbital. You can think about it that way, okay? Now there's 2 electrons which are allowed to reside in that 1s level, and that is it. Once hydrogen acquires a second electron, takes on a negative charge, or else shares an electron in the covalent model, which is by far the much more common case as to sharing. But if it shares that second electron, it's happy. It's got its 2, and it's done with reactivity. As a result, hydrogen always forms one bond. It's never going to be a central atom. If you've got hydrogen in your compound to write a Lewis dot structure for, never, ever, ever put it in the center, okay? Phosphorus. Can it be a central atom? Boy, that's going to be a resounding yes. In fact, if phosphorus is in your chemical compound, I would wager some money that it is going to be a central atom. Maybe not the only central atom, but usually it is the only central atom. Phosphorus loves to be in the center and form multiple bonds. Okay, so it forms multiple bonds here. And in fact, because phosphorus if you look at the periodic table real fast, follow along with me, right? Phosphorus is in the 3rd period of the periodic table. It's element number 15, okay? Z equals 15 for phosphorus here. So if you look it up on the periodic table, look at its positioning. You'll see that since it's in the 3rd period, it potentially has d orbitals available to it. And that's actually a key criteria or condition we're having what's known as an expanded octet. This is where the central atom actually shares in more than 8 electrons. Sometimes it can be 10, sometimes it can be 12. And phosphorus is an example of a compound that does that readily. Okay, so this is almost always a central atom. Never a central atom. Nope. Generally not, except for fluorine. But oxygen can at least possibly be a central atom, but it's not common.